What is going on, everybody? Welcome back to another video of Cup of Code 01. This is another video in the series of 100 Days to Python Mastery. Today you can see we're only knocking out a few lines of code. Not that this is extraordinarily difficult, but this ends our exercises in terms of the conditionals. The last couple of days, everything's been conditionals, either conditions with comparisons, let's say if it's greater than less than Boolean operators, and if loops, for loops. Not so much with whiles yet, but we got a while loop going on here today. While loops can totally crash a system, which you can use for good or for bad. So with that being said, let's rock and roll. I do have the debugger going because we're going to utilize the debugger today. So first off, we're going to write a program that's going to get the sum and the average of n number of integers. So we need to get, excuse me, we're printing out, give me some integers, and then type 0 to exit. So what that's going to do is we're going to type in a bunch of integers, however many we want, doesn't make a difference, there is no limit. And then when we're done, you type in 0 and hit enter, and then that will then take us down into the rest of the code. So let's do that. So I'll type in, I'll do 54, 6, 112, 56, 99, 67, 4, 3, and 77, and then I'll type 0 and hit enter, and you'll see that then it's no longer asking for inputs. I can F8 down. Looking on the left hand side, count equals 0. That's just because that's what I set the variable for in the count variable. Sum is also going to equal 0 because we're just creating those buckets in memory. Number equals 1. So while number is not equal to 0, number equals the integer of the inputs. So the inputs is we put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Technically, we put in 10 inputs, and that's going to come into count later on because that 0, even though we were using that to exit, it's still technically an input. So number equals integer of the input. So you see number equals first one is 54. So number equals the integer of the input 54. Because the 54 that we put in, we typed it in, so it technically was a string, so we're converting it over into an integer. Then we're saying the sum equals the sum plus the number. So the sum right now is 54, because the sum equals the sum, what's in the bucket was 0, plus the number variable right now is 54. Count equals count plus 1, but we can shorten that with count plus equals 1. So right now my count is 0, but when I go through this, the count is going to be 1. I'm still within my while loop because the number is not equal to 0. When I go through that next line there, we have number equals integer input. The next number is going to be 6. So if I look at the top, number is going to go from 54 to 6. And then sum equals sum plus number. Well, the sum is currently 54. The number is currently 6. So the sum is going to now turn to 60. And the count's going to go to 2. And I'm going to go through this for the numbers, but I'm going to stop when I get to 77. So same exact process, taking the number, updating the number with the latest one in the list, adding it to the sum, changing the count. I just want to wait till I get to number 77, which is now. So this is important. So my count's at 9. We know we have 10 inputs. The sum's at 478. Number right now, the last number that was used was 77 in the input. When I hit F8 now, whoops, I went past the number variable. Number equals the integer version of the input. Now, if you look on the right-hand side in our debugger, what was the last number that I put in? The last character was 0. So the integer version of 0 is 0. But now my number in the variable memory is 0. And look at the very beginning of our while loop. While number does not equal 0, do this, 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 and this. But now our number does equal 0, so we're not going to do that. So that should kick me out. Count's going to go to 10, which the numbers are. Number is what? 0. While number does not equal 0, while loop is out. We jump down to the next executable code, which is the if count equals 0. But now look at our count. What does our count equal in memory? Equals 10, which is appropriate because we did have 10 characters that we put in. If count equals 0, print give me some numbers. Else print sum and average of the above numbers are. It's going to give me the sum. The sum we've already computed, so I know it's going to be 478. And then the average, you know, that's going to be our mean. We're going to take our total number divided by the number of inputs. So our total number is 478, but our inputs is not 10, even though the count is 10, because the 0 that we put in was only there to get us out of our while loop based on our coding. So we actually have to do count minus 1 to get 9, because if you actually count the digits we did put in, 1, 2, 3, 4, 5, 6, 7, 8, 9, this last 0 was just to, see here, type 0 to exit. That was just so that we could get out of this while loop later on in the code. So it's going to be the sum's 474, and then it's going to be 474 divided by 9, and we're going to get 53.111111, and you could have formatted that also. If you did not want that to be the float, you could have made that an integer as well. But that's the first part of the program. Now for some more math, we want to create a multiplication table. So chosen equals, chosen meaning you're going to choose a number, the user is going to choose a number. So we're doing an input, give me the chosen number, and since I'm typing it in, it's a string, and I want to turn it into an integer so that it's appropriate. So I'm going to F8 through that. It's going to say give me the chosen number. I'm going to choose 6 and hit enter. Now I can see in my variable side here, pointing to the screen again, you think I'd learned by now. Chosen is 6, that's right here, and now I have for I in range of 13. Why 13? Remember, ranges are going to start whatever we start them at, and this one I didn't put a start in, so it's going to start at index of 0. It's going to go up to, it's going to include, and then go up to but not include the end of our range. So the end of our range is 13. So this is going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It won't include the number 13, but 0 to 12 technically is 13 elements. So for I in range 13, print chosen. Chosen is what I put in, so it's going to print 6, comma, x, that's in quotes, which is going to be the letter x, like times. Get it? Multiplication. Tricky. Comma, I, so that I is going to change. It's going to go 0. The next time we run through the for loop, it'll be 1. The next time we run through, it'll be 2, and so forth. Equal sign, and then chosen times I. So each time the I changes, so too will the chosen based off of the input that I put in. So let's run through this loop. So I already put in 6. So I'm going to F8 through. I is going to start off at 0, like I said. Printing the first one, looking on the right, 6 times 0 equals 0. Well, chosen was 6, x is times. The I is 0, so 6 times 0 equals 0. That's the chosen times I. Now we're going to go, I is going to turn to 1, and now I'm going to have 6 times 1 equals 6, because chosen times I. That's that. The answer is actually being generated by the chosen times I, chosen times I. So we're going to go through this, and the reason I did a range of 13 is because 0 to 12 is the multiplication table, at least in the US. So there we go, 6 times 12 is 72. Now I equals 12. This was for I in range of 13, which technically we're done. It's going to jump out of that program, go to the next executable line of code. So this was fun. I actually used this with my 5-year-old and my 7-year-old when they were learning the multiplication tables, just to learn, for them to learn to code. They would actually type this out. It would take them quite a bit of time. They're copying exactly the code as it's written, and then doing it for the different multiplications. So each day we did a different multiplication table, and they could see, number 1, how it's working in code, and 2, what the actual math is. Lastly, we just have make a program that will print a number and its numerical value in characters. So what does that mean, its numerical value? Well, if the number is 5, then I want it to print 5 characters, whatever the character is. So I'm going to, let's get rid of I, because I don't want to confuse things. Let's make it a $. So whoops, where are we? So let me, I don't want to go through all those other pieces. Actually, it's not that big of a deal. I'll just do 12 and 3 and 0. That'll calculate that. Give me the chosen number. I'll do 6 again. Cool. Can't multiply a non-integer by a string. And that would be appropriate because that is a string times a string. Oh, that's why. It's not going to allow. Yep. It's not going to permit it. I had that problem. Let's do 5 this time. I had that problem the other day because it's trying to print out an integer piece, and the I is constantly what's changing. I forget what it was for. When I go through the code and I create the video for it, you'll see it where a number of times I say it doesn't matter what you pick here, but there was it in Folium? There was one of the libraries we were using, and I was utilizing one of the elements, and it told me that I can't use a name. So I went to a letter. I think I went to like the letter P. And then it told me you can't use the letter P, but it told me what I could use. And it was like 7 or 8 different choices. So sometimes that input does matter. I was putting in a $sign. The reason it was saying no to that is because I was putting in a string, right? Because I put it in quotes. The reason it was telling me no is because not that you can't do a string times a string, but the I is not a string. The I is an integer in this example because of the for loop. And you can't do the string times the integer because that doesn't make sense. It's almost like when we were doing the Panda series and we're trying to calculate the mean on continents. It doesn't make any sense. So for I in range 10, so 0 up to 9, print string I times I. So the string of I is, remember, it's going to be the string representation of the number. So for the first one, if I was to, yeah, let's do it for fun. Whoops. I'm just going to run the debugger on this. I got to first load it in the interpreter. So that's going to be test. I'll load it up and let me run the debugger. Debug test. I want the console. Sweet. So let's F8 through this. So I is first going to be 0. So the string of integer 0 is 0. And then times 0. So it's only going to do it one time. Or 0 times rather, I'm sorry. 1. The string version of integer 1 is just 1. 1 times 1 is 1, so we're only going to see the number 1 show up once on the right-hand side. 2, the string version of integer 2 is just the number 2 times 2, so we're going to get 2 times 2, or 2 times. Because remember, strings, you may have said 4 in your head. When I do 3 times 3, you're going to think 9. You're not doing 3 times 3 because it's the string representation of the number 3. And remember, when we multiply strings or we add strings, it will just do that many. So if I type in the word dog times 3, it'll do dog, dog, dog with no spaces. If I do dog plus 2, it'll do dog, dog. So we're doing a string times a number. So it's going to take that string and then just do it that many number of times. That's it. So that's why 2 times 2 is not 4. String 2 times 2 is 2, 2. String 3 times 3 is 3, 3, 3. String 4 times 4 is the string 4 times. That's it. It's not going to be 16. And it's going to go through this up until 9, and then it's going to finish its process. So we built what looks almost like, well, not like it is, a right triangle. And that's just it. So it's just printing out the numbers, doing that in a sequence, utilizing a for loop. Try this with, so take out, you could do string I, but instead of a string of I, you could put string dog times I. And it's, well, let's just do it. It's not going to make a difference as long as I actually make it. So now all I did was I made dog a string, and now it's going to print it out each for I. So it's dog, 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 and just going down the list, because again, we're doing a string times a number. It's not going to actually give us the mathematical operation of that number just because the string happened to be a digit. So this seems to make more sense to people, the dog. So when I is 3, dog times 3 is dog, dog, dog. Oh yeah, it makes sense. But when the string is 3 and they go 3 times 3, they're thinking 9. It's not. It's a string 3 times. So that is it for today's video of 100 Days of Python Mastery. Take the code, do what things I'm doing, play with it. So for example, someone's going to take, when they first start off, they're going to take the I out and they're going to put dog, and they're going to try to run this, and they're going to get an error. It's going to say name dog is not defined. And they're going to, oh crap, so I got to make dog a variable, so I got to say dog equals something, and you don't. I'm just, here I told Python, by this notation, by this syntax, that dog is a variable and it should be named somewhere else. But once I put quotes on it, like that, now Python knows, oh, so the string is just dog. That's all it is. And I'm not looking for a variable anywhere. So now when you run it, it's going to actually do the code. So don't always think that it just, it's unnamed. It hasn't been defined. You have to go actually define something. Usually it's syntax things. The majority of Python debugging, this goes for any language, is a syntax error, which is you're missing a quotation or a parenthesis or a semicolon somewhere, or your indentation is not exactly perfect, or you misspelled something. I've seen that a bunch of times. When we get to the pandas areas and NumPy and even machine learning, sometimes one letter you keep writing tip, 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 and then you write tips, and then it says tips is not defined, and you're sitting there going, what the hell? Yes, it is. But technically it's not. You have to keep defining tip. So it's things like that are the majority of all computer language coding problems. So take the code. Let me go back to the main screen here of where we were. Take this, play with it, break it, try different scenarios. Going forward, we're not going to hit, we'll always have for loops, while loops, else ifs, and so forth. But play with this, try different things, understand. Again, the whole premise of 100 Days to Python Mastery is, to get you to learn syntax and get you to learn coding and doing these exercises. But it's just as important just to learn how to read this stuff and how to start training your brain to, one, get the muscle memory for actually typing these things, because we don't speak like this, and we don't normally type like this. So even the characters and the syntax is very different. The other aspect is to learn to start to think logically and creatively. Because you might know how to write the letter A, but when you have to actually do it on a 7x7 matrix, you might be going, crap, how the hell do I do that? How do I convert that? How do I convey that? How do I speak it in the least amount of lines? Or at least, number one, get it done, and then try to make it prettier or shorter. So do not get discouraged. Please, by all means, just keep writing the code over and over again. Erase it, do it over again, follow along again, rewind the video, go over again, choose another video, keep doing it. I promise you, weeks from now, months from now, you look back at this stuff and it's going to seem childish. But that's the idea, because then by then you'll be moving on to much bigger and larger modules that we provide. So please, any questions or comments, drop them down below. Make sure you subscribe so you know when we're putting out more videos. I typically try to hit a new one each day. So please keep visiting, keep watching, keep throwing comments, and keep learning how to learn programming and how to read it. Take it easy, guys. Have a good day.